Basic Calculus Part 1, dealing with limits. This is the introduction to calculus right at the start, and the first thing we need to look at is limits, as calculus is based to a large extent on limits. The limit is a value of a function as it approaches a particular point. As the x value approaches a certain value, we look at what the function or the y value is approaching. What does f of x equals 2x plus 5 approach as x approaches 7? Well, quite simply, let's just substitute and see what happens first. There we are. A lot of maths is that. Try it. And if it works, it works. If it doesn't, then we start worrying about it. Yeah, so f of 7, 19, that is what f of x approaches. There's the notation for a limit, and it says limit of 2x plus 5 as x tends to 7. So let's have another example. In each case, we just substitute our number first to see what happens. Yes, it's fine, 15. Notice in this one I write the -3 in brackets. Don't write it without the brackets, because -3 squared without the brackets means that the negative is not being squared. And we do need to square the negative when we substitute -3. We have a name for that sort of term. It's a constant. And what does the word constant mean? Not changing. So if I had to find g of 1 when x is 1, this is constant. Its value is 7. So when x equals 6, its value is 7. So therefore the limit of g of x as x tends to 6. I substitute 6 into that. Well, when I substitute 6 into a constant, I get the constant right back. There's no x for substitution. Another limit. Notice we end up with 1 over 0. We cannot divide by 0. What do you need to multiply 0 by to get 1? Well, it's impossible. That's really what a division says. What do we need to multiply the denominator by to get the numerator? So, and it's not equal to 0. So please don't say that 0 over a number is 0, 0 over a number is 0, but not the other way around. So that's undefined, but it seems strange. It makes no sense in saying there is a limit, but it's undefined. So we just say there is no limit, or the limit does not exist. Pause, try the first exercise. Here we are, that's 0. 0 over -2. 0 over anything is quite acceptable. No limit, because we're dividing by the 0, the 0. When we substitute in, we get 0 over 0, 0 over 0. Now, we could just say straight away, well, and note that's not equal to 0. We could say no limit. We could say 0 over 0 is undefined, which it is. But this is an indication to you in limits. This is what's called indeterminate. Later on, when you're doing more complex calculus, you'll find that also if you end up with infinity over infinity, it's the same thing. It's indeterminate. What it says to you, this limit could actually exist, but you need to go back and work a system. So I'm going to go back. Because have a look at this. I'm going to substitute. X is tending to naught, so I'm substituting 1/2, quarter, 1/10 to see what's happening. As x gets smaller, look at the pattern. Naught, negative 0,5, negative 0,75, negative 0,9. There seems to be a pattern there. If we did 100th, you're going to find that it's still a negative number, and it's not quite at -1. And no matter what you do, the smaller you get, you won't ever get to -1, but you can get as close as you like. There does seem to be a limit. So we're going to go back and say, well, what can we do with this? Well, have a look at the top line. Grade 9 mathematics. Common factor. There we are. Now if you have a look, we can cancel the x's. We're not allowed to cancel noughts. We're not allowed to cancel zeros. So if x was equal to 0, we cannot do that. But x is not equal to 0. X is tending to 0, but it's not 0 itself. So we're allowed to cancel the x's, and there we are. Now we can substitute, and there's our limit, -1. And that's what those numbers were doing. Remember? There we are, going towards 1. Here are some further examples. Every time, always substitute first. Don't show the substitution. Do it in your mind. Do it in your head, or do it on a piece of paper or something. Do it on your hand. And if you get 0/0, look and say, hang on, this will simplify. Some of these give 0/0, some don't. That one did, so we factorize. Cancel those, and we end up with a plus 3. We can substitute. The next one gives you 0/0, so we factorize, we cancel, and we can now substitute. This next one doesn't give you 0/0. In fact, it gives you 2/0. Do you remember that? That's undefined. So we say no limit, or the limit does not exist. D gives you 0/0, so we say, well, therefore, oh, no, it doesn't give you 0/0, it gives you 0/2. What am I talking about? Yes, so that's fine, which is 0. This next one does give you 0/0. Factorize, the w minus 8 can go, and I can substitute. Here's exercises for you to do. Pause, try them yourself. We did the substitution and it came out with a number. Now we're going to look at it pictorially. Points approaching points. There we are. Have a look at this. This is a straight line, and we have a point there that's moving along that straight line towards point K. There we are. Now, that point has corresponding x values and y values. So let's have a look at what happened. As x tends to A, then that point tends to the K, because A is opposite that K. And then as that point tends to there, the y tends to there. So let's go back and have a look at the effect. We have x doing the moving that point to there, and then that point is making the y value move to there. So the limit of f of x as x tends to a. As x gets to a here, this graph gets to there, that point gets there, which means y gets to there. There it is. Let's have a look at a couple of questions involving this. Note that this one has a hole there. There's no value for 6. It's excluded. We had one earlier, remember, where x couldn't be equal to -1, so that graph would have a hole in it. Right. The limit of f of x as x tends to 0. So there we are, x is going to go towards 0. Means we're going to go along there, which means the y value is going to go down. There we are. So what's y going towards? 2. F of 3. That means the x value is 3. What's the y value? So we just read it straight off the graph. There we are. 4. The limit of f of x is x tends to 3. So now x is going towards 3 or x is going towards 3. This is from the left, that's from the right. As it's going towards 3 there, then the point is going along the graph towards 3 and the y value is going towards there. Here we are. And x approaches 3, y is approaching 4. There we are, the limit is 4. Now, of course, that's the left limit, as I mentioned. If you have a look, I'll make it bigger. There we are. 3 with a negative up there means the left limit. I don't know that this is that important for this particular course, introductory calculus, basic calculus, but it's good to be introduced to it. We could go from the right. There we are. We could go that way and have a look, 3 with a plus. But as x comes from this side, the point goes there and y goes there, so it's exactly the same. Right, f of 6. Oh dear, look, we went through the hole. F of 6 does not exist. The limit of f of x is x tends to 6, so x is going along towards 6 or x is going along towards 6. The point is going towards there or the point is going towards there. The y value is going towards there or the y value is going towards there. So let's have a look. There we are, you see. So there's the limit, 6. Here's an exercise to try. Pause, try it yourself. Now, can we calculate f of 2? Well, there's a hole. As confirmed by the equation, x not equal to 2. So the answer is no. There's no point corresponding to x equals 2. Does the function value f of x exist when x equals 2? Well, if there's no point corresponding to x equals 2, that means no. What influence does the denominator have on the domain? So, in other words, the domain is all the x values, and the denominator is the bottom of the fraction. Now, does this denominator influence in any way, not allow certain x values or limit the x values to certain regions? Well, yes. There's the answer. You can't divide by 0, so x can't be 2. Complete. Now we're simplifying. Remember, if we had to try to find the limit as x tends to 2, we'll get 0 over 0. Indeterminate. That doesn't mean we say undefined. It means we go back, we say, well, let's try to simplify. So I've factorized the top difference of squares. Now the 2's can cancel, x minus 2's can cancel, and we're left with x plus 2. So there we are. The f of x equals x plus 2. with x not equal to 2. Check whether the graph on the right represents the function. Yes, it's the graph with the x and y intercepts. Have a look. When x is 0, if you put in 0 for x, you get y equal to 2. If you put in 2 for y, so we could put the x2, alright, we could put it there, you'll find that we end up with that graph there. It's a straight line graph. And x not equal to 2, well, it is excluded. That's why the answer is yes. Complete. If x tends to 2 from the left, we're going that way, from the bottom, notice that as x tends to 2 from the left, this point is tending there, and therefore the y is tending there. So that's why it says f of x, the y value, from the bottom. If x tends to 2 from the right, so x is going there, which means the point is going there, which means y is going there. F of x tends from the top. The limit of f of x is x tends to 2. Well, remember we found out that f of x equals x plus 2. So therefore, but in fact, on the graph we can see what it's approaching. As we approach, we're approaching there. As we approach, we're approaching there. There it is.